welcome back. Hello, testing. Okay, looks like audio is on, so let's take a look at this problem. Here we're dealing again with those thermometers, thermometer factory, and they tell us that if the thermometers are working, then when it's freezing outside, when the temperature is really 0 degrees Celsius, if you take a batch of thermometers from this factory outside, well, the average reading they'll show is 0 degrees Celsius. Not every thermometer will show exactly 0 degrees Celsius, but on average that will be the reading. And the standard deviation will be 1 degree Celsius. And now they're introducing some interesting notation here. They're showing a capital P with a subscript of 40. That's the notation for the 40th percentile of the distribution of temperature readings. And when we talk about the 40th percentile, that means 40% of thermometers would have readings below this level, so then 60% would have readings above that level. So we want to know, if you take these thermometers from this factory outside at 0 degrees Celsius, 40% of them are going to read below a certain value, and 60% of them are going to read above a certain value. And what is that value? So let's get our whiteboard out and look at how we would show the work for this problem and calculate an answer. So here it is, I hope, in a minute. Okay. Again, we always want to begin by writing out our given information, which was that we had the normal distribution with a mean of 0 and a standard deviation of 1. And then I want to draw a picture of my normal distribution. I'll draw my horizontal axis out here. I'm going to take my time and sketch out that distribution. I'll try to get it to look as good as yours will when you draw it with pen and paper. Remembering it's always symmetric, that bell-shaped curve. Yours will look a little better, but that wasn't too bad. And I can shade in my mean with 0. And now I can think, did they give me in this question values for the horizontal or vertical axis? They didn't. Instead, they gave me percentages. They say 40% of values will be below a certain value, 60% of thermometers will be above a certain value. So they're giving me percentages. So what I want to do in my picture is say, okay, well, I know this is a symmetric distribution. The mean has 50% of values below it and 50% above it. So I want a line where 40% are below it. It's going to be somewhere to the left of that mean. And I don't know this number, but I know that the area to the left of it from there to negative infinity, if I shade that all in, I know that this area is 40% of the area under the curve. So as a percentage, it's 40%. When we use our calculator, we need to enter the decimal, so it would be 0.4. And just for completion, we can notice if that area is 40%, because the problem mentioned it, this area from that unknown value marked with the question mark all the way to the right, this area is going to be 60%, or 0.6. We think of that total area as 1. Okay, so we don't know the number marked question mark here, but the notation of the question said this is the 40th percentile. It's P sub 40. So we could fill that in just to have a real detailed drawing. And we're looking for what is P sub 40? What is the 40th percentile? So now we want to think about the two calculator commands we have to use, normal CDF or inverse norm. And whenever we know a percentage, inverse norm is the calculator command that can give us a value on the horizontal axis. So we want to use inverse norm to get our answer here. Inverse norm. Oops. Inverse norm. When you use inverse norm, now we have a moment to think and say, okay, first thing it wants to know is the area. Well, does it want the 40 area or the 60 area? The thing to remember for inverse norm is it always wants the area to the left of the value of interest. So here's my value of interest. The area to the left is 40% as a decimal. That's 0.40. So that's what I got to say into inverse norm. 0.40. Then it wants the mean and the standard deviation. So my mean is 0. My standard deviation is 1. So let's go ahead and enter that in the calculator and see what we get. So if we do second vars, inverse norm, now we're going to do 0.4 and then 0 with a comma in between, and then 0 and then 1. And the number I'm coming out with is negative 2. Let me write it in here. Negative 0.2, negative 0.2533. Let's telling me if I go outside and it's 0 degrees out and I take a whole bunch of thermometers from this factory, 40% of those thermometers are going to say the temperature is less than negative 0.25 degrees, and 60% of them are going to say the temperature is more than negative 0.2533 degrees. So if we want to complete our picture, we'd say, okay, we found out P40 equals negative 0.2533. Let's go back to that WAMAP question just to show how we would enter the answer. So if we go back to the WAMAP question, here we go. We'd want to enter our answers as round to 3 decimal places, so it would be negative 0.253, and let's show the answer, see if we get it right. And we did. Nice work.